For what values of x is arc cos x greater than or equal to pi over 2? Now, there are two ways to do this. One the using the unit circle appropriately, although that can be quite confusing because you've got to interpret things properly. Let's do this with the graph. I think it's really important to have a strong feeling for what the graph of arc cos looks like. With all of your core classes, if you can't kind of just cold write down the graph, you've got a problem, because if you're being asked to do something complicated with them, it could be just, if you don't know what it even looks like, you've got no hope. So let's think about what arc cos looks like. Let's write the graph down. So the graph's kind of weird. But if I do y is equal to arc cos of x, what does it look like? Well, it's kind of strange. It's this reflected piece of the cos graph, but it looks like this, doesn't it? Kind of like that. And let's kind of mark the key points on it. So we've got 1 here, we've got minus 1 here, we've got pi here, and this point here, very important, is pi over 2. Okay, and it's inclusive of endpoints. So what are we looking for? We're looking for the x such that the arc cosine is greater than or equal to pi over 2. So that means we're looking for all the positions where it's above, let's get this right, it's got to be above that line. Goodness. It's got to be above this line. So this is me with y is equal to pi over 2. So we're looking for the inputs which are above the line. Well, clearly that's going to be all this stuff down here, from there to there. So from the graph, arc cosine of theta is greater than or equal to pi over 2 if and only if x is in the interval -1 to 0. -1 to 0. So you could do that with a unit circle, but I think you want to get really good with the graph of arc cosine, and this is a good use of it.